All right, guys, we're going to burn through this Suzuki file really quick. We're going to find some sensor scalar linearization maps and some DTCs and kind of how they're working. This is a Suzuki Sidekick or Vitara or Swift. It's a M16A 2009. Somebody sent it to me. So we're not going to analyze. Let's get our code viewer up here. And we are going to run our Nissan script thanks to Funigrek and all the work that he did over on ROM Raider. Give him a follow on YouTube. I don't know that he does ECU reverse engineering anymore, but he definitely contributed a ton in the past years. So we're going to search 4F22, which is how a lot of these functions start. So we're going to hit search all. Okay, we're going to go down here, click Control A, and then make selection, click D. It's going to work for a minute, disassembling all of these addresses that we just brought up right here. While it's doing that, we're going to find our target map. So we're going to sort by size. Okay, and we're going to find the biggest, 59 by 1. Yeah, so luckily this is 32-bit float. That's cool. Okay, we're going to copy that address, and we're going to go throw it into Ghidra, and there is no reference. So now we're going to search that address. Search all, and there's one. That's really promising. Okay, this is looking real good, guys. So we're going to make that a pointer, and these are going to be bytes. Yeah, this is it. So we're going to highlight that, data, create structure, and this is a 2D, no scalar. And I'll find one that does have a scalar and show you what I mean by no scalar. So this is X axis, and this is Z, map data, and 3B is the length. So 3B in decimal is, what was that, 59? I'm not going to double check. So this is what's referencing it. Here's the structure. So this is a 2D handler right here. Some of this you just need to remember. I don't dive into how this function's working. If I need to, I will, but you need to just remember some of this stuff. All right, so that's an important number, 0762934, whatever. That is a typical factor that you multiply to the raw value coming into your ECU from a sensor like voltage, right? So this is voltage, which was the x-axis of here. This function is calibrating this raw data. Param 1 is our 076. Param 3 was our RAM address. So yeah, that multiplied by that equals U bar 3. So here's our sensor voltage raw. Okay, now let's see what writes to it. So in both cases it's 50B2. And this is a counter right here. So if this statement is true, it resets this to 0. Else, it's not true. If it is under FF, this counts by 1 until it is more than 2. And then it equals the same thing again. We're not going to name that right now. We don't even know what it is. It's voltage. We don't know which voltage. We think it's mass airflow. So raw voltage, okay. Raw voltage less than 5.8, less than 7 AE. All right, we need to look at these real quick. Throw this into WINOLS. We do want to save this map, yes. Okay, 16-bit, high-low. All right, 65,000, and you'll remember that the voltage was multiplied by 0.00076. Yeah, that's right. Yeah. Okay. So this is, well, let's just go back and look at Ghidra real quick. So if UVAR is less than 4.8 volts, this happens. So if it's true, and then it's less than 7 AE, then this equals, okay, so this is our minimum. F857 AE, okay. All right, so we need to go, it is a, there. Okay, so max, min, all right, so that's what we're dealing with right there. That's our maximum and minimum threshold voltage. So if this statement is true, and then this statement is true, so if we're below, so circuit low equals 2, that messed up, that's okay. I don't like to get rid of the RAM address. It's pretty important in my mind to keep that on there. Okay, else. So what's this else right here? So if the first statement is true and this statement is false, so it's under max but not under min, so we're just going to say else equals 0, which means it's good, and then equals 1. So if the first statement is false, so circuit low, comma, circuit high equals 1, else equals 0. Good. We're going to call this calibration. Okay. CVAR equals this. So we're going to copy the front end of that RAM address, post it there. Okay, if it's equal to 0, meaning it's good, else 0. If it's equal to 0, meaning it's good, and this is other than 0, what is this? If this statement, it resets this to 0. Okay, this is a counter. Okay, we're just going to call it a timer. I don't know if it's a timer or counting events. I think it's a timer. I think while this is other than 0, this will be accumulating. Okay. No, while it is 0, this will be accumulating. All right, so if this statement is not true, we jump to here, this timer is reset, and then we check it against 2. So then if this statement is true, so if circuit is low, and this timer is above the value of 30, so we've declared there's a problem. We have counted down our accumulated time. Now we know that circuit low equals 1, and this one is circuit low equals 0. Okay, and the inverse is true. If there's no DTC, the inverse is true. Okay, timer again. If this statement is not true, timer is reset. We're going to check to see if it's not a DTC, and we're going to check to see that it's not low, and we're going to check to see that it's not high, right? check to see it's 0. Then 7 and 1 is ran into this function. That function is used in both spots. If this statement's not true, then if circuit low equals, so we have a true circuit low, and we have a true circuit low, then this function is ran through with the 7 again and a 16 rather than a 1. This is significant. Okay, let's keep rolling. So if circuit equals 0, again, timer's reset. Right here, if this statement is not true and circuit equals 1, which is high for a duration of 30. So after our countdown, circuit high equals 1 and circuit low equals 0. The inverse is true. If circuit, so if we're not and we're not, u var equals this function with 8. The last one was 7 and 1. So no DTC. So we're in good shape. We're 8 and 1. U var circuit, what do we got? Okay. Circuit high equals 1, circuit low equals 0, so we do have a bad condition. 8 and 10, 16. Okay, so I see a pattern here. I think that we need to stop here and go find our DTC table. I should have taken a break and done that already, but that's fine. So let's jump into WINOLS, and all cars have temperature sensors, right? So we're going to go 011. We're going to start pretty technical here and try to rule some stuff out. So we're going to search this. None found. We're going to swap these two because they like to put them together. One occurrence right there. Why is this so wide? All right, so 118, 112, 123, 131, 13. This is it for sure. So these are DTCs. 0300, 31. Okay, we're going to make this long at 272. Oversize is fine as long as it starts in the proper place. So we need to prove that out. I do like it to be vertical rather than horizontal. Okay, 031. So we were 07, 08. Decimal points were 7 and 8. Okay, and those are the wrong. That's manifold absolute pressure, if I remember correctly. Yeah, we're looking for 0101, 102, 103 for the mass airflow sensor. So we're going to break away from the mass airflow sensor for a minute and find another sensor linearization map and compare it to this DTC table and see if there's just like an offset or if maybe we need to add some fill into the beginning of this DTC table. Sometimes they're referenced from, well, oh, hang on. Let's copy this address and let's just jump into Ghidra and see where it's referenced from. And sure enough, we are referenced from the first 0300. So let's put that there, and then 0708. Yeah, that's it. But let's prove it now. So that makes sense that the other one was mass airflow. Let's make sure. Okay, sorted. Where's another? This was one of the ones we were looking at also. Yeah. Okay, let's check this one real quick. So this is obviously voltage, 32-bit float. So we're going to copy this address, throw it into Ghidra, and nothing references it. We're going to search that byte sequence, one reference, which is a good sign. That's going to be a pointer, that's a float, and that's a float. And these, I think just bytes, but they might be double words. We're going to roll with bytes for now. We're going to copy this. We're going to highlight it. We're going to create structure. And this is what I was talking about earlier. So this is a 2D structure with scalar, and I'll show you what I mean there. So This 99 is our offset, and the negative 100 is our, the negative 99 is our factor, 0.009999 is our factor, and negative 100 is our offset. And negative 40 to 119, that looks like it's it. This is going to be intake air temperature rather than ECT. ECT would go higher. It doesn't matter though. So let's look at what references this. Yep, we're looking at all the same stuff. Writes to this is this, just like before. UVAR, here's our circuits, just like before. Circuit high, circuit low. And we're going to look at what reads that. So here's this. CVAR equals 2. These, just like before, 13, 13, and 16, 13 and 1. 14 and 1, 14 and 16 for our circuit high, circuit low. Let's check it. 13 and 14, 112, 113. IAT, circuit high, circuit low. Okay, so we'll jump back into Ghidra, and we're going to call this function IAT, comma, 0113, circuit high, comma, or low high. Okay. All right. This is definitely our DTC handler. If a guy wanted to, you could spend hours digging into these functions and tracking it to the DTC table. And I've had to do that in the past, and it takes forever. It's not fun. I only do it if I absolutely have to. And sometimes you do, because sometimes there's functions that are writing these hex values to RAM addresses, and then there'll be another function referencing the RAM address. So I like to put it in Notepad++, delete the top one to get our 1 to correspond correctly, and our 2 and our 3, right? And then we're going to throw this over in this side right here, and we're going to select Ghidra, and we're going to slide that to there. Now you can roll through your DTC function. Before we lose ourselves, we're going to make sure we label this as IAT handler. Nope, IAT calibration. Okay, this is IAT. This is IATV. Raw. Okay. Okay, let's take a minute. We need to create a folder, and we're going to call it MAF. Calibration, and that's going to be this, and maximum min volt, new folder, IAT cal. Okay, open that one, set that there, jump back into Ghidra and grab its addressing, 7EA, 7EA. Okay, and it's going to be 2. That's correct. 0.00076 15 max min volts. Okay, and dump that into IAT cal. Okay, and this is IAT. Let's double check Ghidra and make sure IAT calibration. And this calibration is mass airflow. So MAF calibration, the first one that we checked, right? And then DTC. So DTC handler and DTC 7.8 is actually DTC P0102, 0103, MAF circuit high, low. All right, so I think that's going to do it for now. I'm going to make another video on how to find like the manifold absolute pressure sensor on this, and we're going to go a different route to find it. Now that we have, we just used our 2D scalars that we found within the binary file to then track ourselves to the DTC tables where we could prove what that sensor scalar is doing. Now that we have our DTC handler right here, now we can use it to find the rest of the sensors and parameters within this ECU. So hit the like and subscribe if you would, please. And I'm trying to get this YouTube channel pumped up. I'm almost ready to monetize, and once I do that, then I'm going to be making a lot more content. I am going to set up a subscription where paid subscribers are going to have access to more detailed content on newer binary files and whatnot. And then I'll keep creating free content also. Like, subscribe, share, check out my website if you want to, and I appreciate you guys watching. Thank you.